Hi guys, today we're going to talk about a very interesting problem in blind 75 series, which is merge to sorted list. The list can be anything, but in a particular example, particular problem, in lead code they're given as to solve using linked list. So they will give two sorted linked lists. You can see this both are in sorted manner. And what you need to do is you need to merge them together and return as a sorted one, written as a single linked list which also need to be sorted. That's a simple problem statement. Now let's dive into this and see how to apply algorithm. Now let's talk about the iteration solution, guys, and I don't want to waste much time on taking a different solution, so let's directly jump into the optimal and correct way to solve this problem. I will also write the pseudocode side by side and walk to the problem, because for linked list kind of problem it's better to visualize the problem as well as the see the code, then only we can able to understand it. So without wasting much time, let's get into it. Initially what we have to do is we need to have dummy pointer. Let me declare a dummy is going to be there, as well as the pseudocode. I will write pseudocode this side. So dummy is going to be, we're going to get a list node. And what we have to do next step, we need to have two particular pointer, p1 and p2. Let's write that also. P1 is going to be list 1, P2 is going to be list 2. And next step, what do you have to do? So just utilize this sorted property, guys. What the sorted property tells, if it's in ascending order, then all the element will be in increasing side, right? You can see all the element is on increasing side. Now let's utilize this, guys, and let's build the sorted list out of this. Okay, now what we have to do, so we are having two different pointer, and now we need to have the smallest pointer, right? We need to have smallest pointer. So now let's find which is the smallest element among these two pointer. Which is the smallest right now? The p1 pointer is smallest. Now let's link this to this dummy node. Let's assign 1 to this, and let's write the appropriate pseudocode for this also, guys. So let's start the while loop while p1 is not equal to null and p2 is not equal to null. What this while loop tells is we just need to iterate until unless if any one of the loop get exist. Okay, now what is the next step? So we are just comparing two pointers, right? So if p1 is less than p1 dot val is less than or equal to p2 dot value. If it's less than or equal to case, you can typically move any one of the pointer. For simplicity, let me have 1 year. Okay, let me have 1 year. Okay, now both the values are equal. Now what we do is you can simply move any of the pointer. So right now I'm going to move p1 pointer. So what we did in this particular place, so we just assigned dummy dot next. It's going to be the p1 node. So dummy dot next is going to be p1 node, and now let's move the p1 pointer. P1 is going to be p1 dot next. Very simple. Now we also need to move the dummy pointer as well. So dummy is going to be dummy dot next. Very simple. Now let's do the else condition. What is the else case? What if this particular node is greater? We just simply assign p2 node here and move the p2 pointer as well. The same approach will do for p2 pointer. Similarly, write else condition and dummy dot next. It's going to be p2 pointer, and we'll also move the p2 pointer. P2 is going to be p2 dot next, and we'll move the dummy pointer as well. So dummy is going to be dummy dot next. It's a very simple code, guys, and I hope we already finished this code. And now what we have to do is we just need to add the remaining element, guys. If we check this particular while loop, this will only end if both the things have similar size. So what if it has unsimilar size? For example, if we take in the particular example, this node has larger element than this node. So what do we have to do at this particular time? We need to add the remaining element to the dummy node. How to do that? According to this particular case, like either any one of the node will be finished off. So we just need to concentrate on only one single node. How to do that? It's very simple. Again, simply write the while loop. While p1 is not equal to null, simply add the node to the dummy node. So dummy dot next is going to be p1, and simply move p1 is going to be p1 dot next, and move dummy as well. Dummy is going to be dummy dot next. Now we just handle the case when p1, I mean when l1 is larger than l2. Now we have to handle the case for this particular case, right, when l2 is larger than l1. Simple code. I'm going to just copy paste this and simply change the pointers alone. We just need to simply change the pointers alone. It's very simple. Instead of p1, just put p2. That's it. Very much simple. p2 dot next. Okay, yeah, that's it. Very simple. Now we just handle the case when p1 is larger than p2, and we also handle the case when p2 is larger than p1. We don't know, right, which one is having larger thing, so we simply need to write code for this thing where we handle two edge cases. And now at last we can simply return the edge. So return, so dummy dot next, dummy dot next. So this dummy dot next will have the merged sorted linked list. Now let's do the quick dry run, guys. And as we see, now we have two values, so we can move either pointer. So let's move the p1. I just move the p1. Now tell me which is smaller. p2 is smaller, so add p2 node here and move the p2 pointer. Now which is smaller? p2 node is smaller, so add the p2 node here, which is 3, and move the pointer. Now if you see which is smaller, this one, this particular node is smaller, so add this. We added 4, and right after adding this we are just moving the pointer, guys. So after moving this, which is smaller? Obviously 5 is smaller, so add this 5 and move the p2 pointer. And again, which is smaller is p2 pointer, so add this 6. Now let's move this pointer as well. Now which is smaller, guys? Tell me. 7 is smaller, so let's add 7 to the list and we'll move the p1 pointer. Now p2 pointer is smaller, so simply add 9 to the list and move the pointer as well. And now 10 is going to be smaller, so we'll add 10 to the list and we'll move this pointer. And which is smaller right now? 12. So let's add 12 and we'll move the pointer. Now if you see, we just reached the end pointer. Now what we have to do? So we have to see the edge cases. Right now we have some remaining elements in p1. So how to handle this? We already seen how to handle this. This particular code will handle this thing. So according to the code, what we did is we just iterate the remaining p1 pointer and add remaining element to the dummy node. So let's do the same. So right now we just add only this particular node. So we just simply add 13 to the result. Now if you look at this dummy node, it is already in a sorted format, guys. Now if you look at this particular node, it's already in a sorted format. We utilize the property of sorted and we just build the list out of it. And we can simply return dummy dot next. So dummy dot next will point to this particular head, and this head will have this all the nodes. I hope you guys understand this particular problem. Now let's code this up very quickly. So before that, let's talk about the time complexity, guys. What is the time complexity of this particular problem? So time is going to be big O of 2n or big O of m plus n, where n is going to be size of list 1 and m is going to be size of list 2. This is the time complexity. And if we talk about the space complexity, we are going to have big O of 1 because we are not using any additional data structure. By just using two particular pointer and building the list out of it. It's very simple. Okay guys, now let's declare a dummy pointer. Dummy is going to be list node. In Python, in Python we used to have list node as a linked list data structure. Now we need to have a pointer, right, to access the dummy node. So let's declare that also. So temp is going to be dummy, through which we'll access the dummy pointer. The dummy node. Now let's declare the two pointer p1 and p2. So p1 is going to map to list 1 and p2 is going to map to list 2. Very simple. Now we'll start the while loop while p1 and p2, which indicate if any one of the pointer is ending, we'll loop until that. And what is the base case? The base case is if p1 pointer is less than p2 pointer. In that particular case, what we do is we just attach dummy node to the p1 node and we just move both the pointers. And if the condition fails, which means the p2 pointer has minimum value, So we attach the minimum value to the dummy noder and move both of them. Now let's code this up. If p1.val is less than or equal to p2.val, simply attach temp.next. It's going to be p1 node, and let's move the p1 node as well. P1 is going to be p1.next. And else case, what we did is I just did small typo. Okay, I have fixed it. Now temp.next will be p2, which means list 2 as a smaller value, and we just move p2 as well. P2 is going to be p2.next. And I mean, at every single position we have to move the dummy, right? So I'm just moving. Temp is going to be temp.x. I can write inside this two if condition, but it's not necessary because either way we're just going to move the dummy node. So I will do this outside of the loop. I will do this outside of the if condition as well. If not, I have to write two times. I have to write like this. Instead of that, I can simply write only one single time outside the if condition. Now let's handle the edge cases, guys. Like, what if p1 pointer has some nodes? What to do at that particular case is simple. While p1, if p1 is exists, we simply add temp dot next is going to be p1 node, and we just move the p1 pointer as well. P1 is going to be p1 dot next, and we also move the temp is going to be temp dot next. We just move the pointer, and again, so what if p2 pointer has nodes? What to do? Simple, same code. Instead of p1 we just write p2. So p2, we just move the p2 pointer, simple, and we can simply return dummy dot next. Let's submit this and see. Yeah, it's working fine. Now we'll test for all the test cases. Submit. Yeah, it passed all the test cases. You can see it took 1 ms and minimal space as well. I hope you guys understand this particular problem, and we'll meet again in one more video. Until then, bye.